everyone. I hope you all having a fantastic time at Test. I'm Cypress, and it's my pleasure to introduce you a session that I believe will resonate deeply with many of you. Today, we're diving into a very interesting topic, which is empowering teams for autonomous quality excellence. Now, this isn't just about improving processes, it's about fundamentally transforming the way we approach quality in our teams. Our speaker, Anton Necheukhin, head of QA at Miro, is going to take us through a remarkable journey, one that started with sort of a traditional QA approach and evolved into something which is today truly revolutionary. Anton will share how Miro transitioned into a model where half of their teams operate without dedicated QA engineers. Yes, it looks surprising, right? And yet, quality has it's just not been maintained, it's been elevated actually. So, this session will cover the blueprint for QA decentralization, the critical component of this shift, and how it's empowered teams to take full ownership of quality. Anton brings a wealth of experience having led a large scale QA initiatives across different environments. His insights into how Miro achieved this level of quality autonomy will provide you with actionable strategies and inspiration for your own teams and your own organizations. Uh, so, if you're interested in learning how to overcome internal barriers, establish a strong QA community within your organization, and drive your team towards autonomous quality excellence, this is the session for you. We're going to have the Q&A, so keep posting all your questions in the Q&A section. We're going to take them up if we have some time. And here goes Anton live. So, Anton, let's get started. Please join me in welcoming Anton Necheukhin.
Thanks a lot, and I hope you can see my screen. I'm Anton, and I'm super excited to be here, and I want to talk a bit about how to make sure that everyone is responsible for quality. So my plan is to cover prerequisites first, because to be able to achieve that and actually empower our teams, we need to provide them with tooling, infrastructure, processes, and all needed things. Then, if it becomes responsibility for everyone, I would cover the roles and those responsibilities. Then we are doing a significant change, and we have to measure our success. Like it is an approach how to do that. And it is our practical experience, and generally, I'm not talking about theory. So we will share how we measure that success and what we probably offer to do in your environment if it is applicable. Then I will talk about supporting functions like QA community and enablement. Also, I can't say that the story is fully successful, and because of that, I would share not only results but also consequences of that. Then, actually, the final step within this journey is QA decentralization. It actually means that our QA engineers would report to engineering managers within teams, and they will be fully part of those product teams. It doesn't mean that initially we had one dedicated team responsible for testing. Of course not. Our QA engineers were distributed between product teams, but the reporting system was centralized. QA engineers reported to QA leads, and QA leads to me, to head of QA. But the ultimate goal is, of course, not about the QA decentralization or to change management. The end goal is to make our teams autonomous. It actually means that they are self-sufficient and they can make decisions about who is doing what in their team. It can help us to be sure that they are accountable for everything, including quality assurance. It can work at scale because we don't need to think about how to scale QA structure according to the engineering growth. But we still want to keep some connection to be able to be sure that our practices are consistent across the organization. Because of that, it is a matrix management where we still have dotted line management. And if a QA engineer reports to engineering manager, there is a dotted line between QA engineer and QA lead anyway. So let's start from prerequisites, because actually, if we make our teams autonomous, they need to have convenient tools for that. And the first thing is QA process. I will go through the process quite quickly and actually highlight only essential parts of it. But if you scan this QR code, or afterwards probably you can find the link behind the like article name, you can find my article which describes in detail. So the first step is accepting user story. It is about the initial step where product manager brings a problem statement to the team, and product manager is a person. So any even mature people couldn't predict any details, and to be able to decompose those business requirements, we can use general practices like 3 Omega sessions where QA engineer, 1 or 2 developers can sit together with the product manager and think about the story overall and try to decompose it into details. So such practices like example mapping we heavily used in our practice. And the end goal is to have clear acceptance criteria. Generally, it means that like from the beginning, we don't have any questions from product perspective how this feature should work. The second part is refinement. It is more technical part. The end goal for this stage is to clearly understand how this new feature should be implemented from technical perspective. We need to have solution design. And it's not about how we imagine that it might be technically implemented. We need to be sure that developers could actually check the code where we are going to contribute. And we know all the specifics and hidden challenges, and we are trying to consider them during the technical design. Then, if we've done those 2 parts fully, we know all the details from product and technical perspective, and planning is a simple stage where we can just move top tasks from our backlog to a sprint. And like we can set clear acceptance criteria and sprint goal, and sprint goal will be realistic in this case because like we again know the details, we know the complexity, and the goal will not be like to implement feature. Like we know what we can do in 2 weeks, and actually this will be the goal for us. Another thing which is probably essential, especially from the beginning, if our developers, for example, didn't think about testing before, it is probably better to explicitly mention what we need to test and how in tasks, or even have some dedicated tasks for that. It is needed from the beginning. Once our teams get used to thinking about testing, it might be clear and obvious by default, but from the beginning, it's better to consider. Then development stage, and what helped us significantly is that we stopped testing after developers. And the QA engineer is not a person who should test everything that the developers implement. It helps to fully delegate quality to developers because they know that nobody after them will check it. QA engineer might cover functionality by end-to-end tests or do another work. Again, our teams are autonomous and they can decide by themselves what they need to do, like which roles are. And but the essential thing that there is no repeatable loop where QA engineers check the same things several times. It helps on the release stage to do exploratory testing. So usually when we release something to production, it is hidden from customers by feature toggle. It is already in production. It could break something because like the code has been changed. But at the same time, again, feature is not available. At this time, we can check positive scenarios, and product managers can do that, not QA engineer, because finally a product manager can check if the new feature introduced in a way how like the manager imagined it from the beginning. And QA engineer with his fresh mind can do additional testing, find things that were not predictable, or do additional performance testing, maybe security, maybe something else. So the typical work for testing was covered by developers, by actually product manager, analytics, maybe other roles if you have them in teams, even designers. And the engineer is doing the additional validation, and it helps us to have another level of quality. As a result, you can see that, for example, in one of the teams, we implemented two comparable features, and one of them was USM and another was Kanban. And USM was done in a traditional way when QA engineers tested everything that developers did. And you can see that it took much longer than Kanban, where we could try to predict everything from the beginning and design solution better. Of course, such additional work like decomposing business requirements and technical solution take a lot of time, but in the end, having less iterations in total gives us an opportunity to deliver features much faster. So this was the first precondition about QA process. The second is tools. And I won't spend a lot of time for that part because it might be specific for a product based on the technologies that we use. We designed our own approaches, which level of tests we use, and it might not be applicable for you. But I want to mention that you definitely know that usually on functional level, we have infinite amount of tests to cover. And if we deliver and develop those end-to-end tests in isolation from other levels, we will have too many tests and not enough at the same time, because it is impossible to cover all of them. And because of that, the main point is that it should be a conversation with developers from the beginning, how our different levels of test can complement each other. Then infrastructure. And there are three maybe absolutely typical approaches. The first is local development, and it is crucial part. So because local development drives us to have better architecture in the future. If we can develop a component in isolation, knowing clearly dependencies, it can bring us better architecture in the future. Sometimes local development requires additional develop environment. For example, if I am a front-end developer, I want to start my client locally, but not start backend. And I would use remotely started backend somewhere. So for that needs, we can use develop environment. Then test environment, where we execute our auto tests. So we fully automated regression and any kind of testing actually years ago. And we use testing stage for that. And staging as a completely similar environment to production that might be used for investigations and other use cases. Once we got everything, processes, tools, frameworks, and so on, and infrastructure, we started considering QA decentralization and faced such challenges. The first is our QA structure is based on QA leads anyway. So the idea that we have huge streams, some kind of departments, and for every stream we would have a QA lead. It is actually like head of QA role, but not for the entire company, for some specific stream. We had 6 streams at this moment, and we actually needed to hire 6 head of QA. And you probably know, if you try to do that, it is challenging story to find so mature and like relevant people who might combine technical and managerial experience together. Then we develop like set of products which are connected to each other. It actually means that if we change one product or one part of the product, it can affect others. And of course, communication can solve the issue, but at the same time, it's really difficult to have like perfect communication approach. So we needed to have quality. What we need to do to develop quality across the entire organization. Our approach was to define QA strategies in all streams. So practically, it means that in every stream, we could identify gaps, quality gaps, some issues, process issues, maybe lack of test coverage, maybe technical challenges or architectural, like tech debt or something else. And then it was a plan in every stream what we are doing, why, like some kind of measure or QRs related to quality and so on. So I don't want to say that it is a like constant approach which we stick to and that we still use, but initially it was an essential thing for us to understand what is happening in those streams and what we need to do, what kind of tooling we have to provide, and so on. And the last one is that our engineering historically was structured based on product needs, and like we had ownership for product features, but sometimes we could not have clear ownership for every technical component, which could cause bugs or any kind of quality-related issues. We couldn't restructure the entire engineering because of the quality needs, but we could clarify the ownership for all those missing technical components. And to summarize, you can see that the role of QA lead transformed from management to IC to an individual contributor, because QA lead doesn't have direct reports anymore. Again, QA engineers report to engineering managers. And the scope became much bigger, because if you had a structure, the structure was nested, and we could spread responsibility between different like QA leads and maybe have more people involved. Now we have one QA lead per stream, and each stream is huge. In reality, even we have cases when one QA lead is responsible for several streams, and actually expectations from those QA leads became higher. Behind this QR code, you can find another article which is explaining QA lead role in detail. Then, actually, the most significant change in terms of roles and responsibilities is for engineering managers. Because before the QA decentralization, when we asked engineering managers to be care about of quality, they could say that how can we do that if the main resource, which is like QA engineer, is not under my control. Now, when we decentralized and one QA engineer became fully a team member within the team, engineering managers became fully accountable for quality. QA engineer is still responsible for lots of listed aspects here, but in a way that the whole team should be responsible for quality for some particular elements of that. And QA engineer is coaching and engaging in those practices. QA lead is more consulting role at the moment, but you can see accountability as well. And it is for tools, infrastructure, technologies, practices, because in common frameworks and infrastructure might not be like fully applicable in some specific environments. And QA lead is a great expert in QA craft, and QA lead can adjust common practices and approaches how to use different frameworks in their environment. For me, for head of QA, to be honest, there is no significant change because I still have the same responsibility about I need to ensure that our product is a high quality product, and I still have influence across all streams to improve the situation. What has been changed is that I can't just say to QA leads or QA engineers or somehow else, you have to do that, because I don't have this power, I don't have direct management. But I still can explain using business language why we need to do that. And if it is really clear, if we evaluated impact and effort, it will not be a problem to initiate something in any organizational like part of our company and any structure, at least in our case. And several words about career matrix, because you can imagine if engineering managers became responsible for key engineers' career progression, and engineering managers might not be experts in QA craft, it might be a problem. Moreover, expectations from QA engineers might be different for engineering managers and for QA engineers. And it might be because engineering managers might not know how this paradigm of distributed ownership should work, or maybe opposite situation, that they have strong opinion but QA engineer didn't have this experience, or maybe again opposite, QA engineer knows how to do that but opinion is different. I mean, it is very, very important to catch such cases of misalignment in teams. And if it is happening, we have to fix those conflicts as soon as possible. Otherwise, we can lose great QA engineers, or it might be, I don't know, bad atmosphere in the team, and it will not have the situation and quality in general. Then, to be able to be sure that we are moving in the right direction, we have to measure our success. You could see that our prerequisites were like processes. It actually means that we were trying to find a way how to deliver high quality. So we changed processes, and we are trying to see that it is efficient. I mean, we were measuring processes, we were measuring outputs. Here, once we delegated it fully to teams, we need to measure the result, so that the delivered feature is good enough. So it is an outcome, and this is a significant change. The new approach looks like this. We have 4 basic metrics and 2 buckets. The first bucket is bug density. Here we have OA, which is a percentage of bugs that we can fix on time. We have several severities and different expectations for those severities, but always an overall metric for all the bugs. And mean time to resolve. It is an absolute number to check, for example, if a team fix critical bugs in 5 hours. Or is it good enough for us or not? Second bucket is testability, and metrics are obvious here, like test coverage and test efficiency. Like test efficiency consists of flakiness and speed. But it is not really obvious from like methodological side, because when we have traditional approach, we usually have bugs found during the development and bugs detected in production. Comparing those numbers, we can say something about our QA system efficiency. Here, like we delegated testing to developers. We can't ask them to track all the like found bugs during the development. It is useless work, and they will not be happy with that. And it is okay. It is shift-left testing when we use automated tests and any kind of testing approaches during the development. If we execute a test, found bugs, and can fix them immediately, it is great. It actually means that we use those tools not as a final stage to do a regression. We use our tests to be able to develop faster. It is shift left testing again, and because of that, we started measuring the stability, not how our QA structure efficient is. Then next part is about 𝐀𝐧𝐭𝐤𝐧, which was the horizontal team, and there were QA engineers only. Now, when we moved to this model, not every team can have QA engineer actually, but we need to spread our practices somehow. So it actually means that QA community is not only for QA engineers anymore. QA community is for alignment around our goals, targets, KRs, and it can help us to keep product quality consistent in different parts of the product. Then we can develop practices together. For example, if one of the teams implemented a new approach how to do integration testing on client side, we can share that and others can reuse. We can also onboard engineers to common practices, frameworks, and so on. We can have a bridge between product teams and QA enablement, a bit later about QA enablement, collect feedback, analyze results, and make improvements. I wouldn't say that we could start doing that fully efficiently. For example, we don't have representatives from every team in QA community. But a lot of things work pretty well. Like, for example, we really share new approaches which were successful in those teams, and we are making them common, and then other teams use it. So it works pretty well. Then QA enablement, as I said, probably before, it is a set of dedicated teams who are responsible for developing test frameworks and infrastructure. And how it actually works in reality. So here you can see that QA enablement and together in cooperation with QA leads can create strategy and provide the needed tools and infrastructure and then implement it in practice. So how it works? Let me share it by example. We decided that our approach is to use schema validation for covering contracts between microservices. We analyzed different options and decided that contract testing is not our option. It means that we will develop buff for gRPC, and we will not provide any opportunities to use Pact.io, for example. It actually means that we support the QA strategy by right tools, and we are not providing something that we don't believe that will help us. Then practices and standards how to use those technical technologies might be developed by people who daily use that. It is community. And then QA leads can really implement that changes in practice because they know gaps, like quality gaps, and they can bridge them and introduce some KRs in streams, actually justifying by needs. So those, like, for example, contract tests we need for keeping our microservice, like the entire system stable, and there is a potential issue or maybe existing issue in streams, and to be able to solve this issue, we need to do that. So the QA leads set baselines. Consequences of the QA decentralization is that more than half of our teams are without dedicated QA engineers, and the trends the trend is to decrease number of QA engineers. Fortunately or unfortunately, but it is so. I would just say that maybe like in the next slide, we will see that more people involved in reality to quality. And again, it's up to teams to decide to have a dedicated QA engineer or not. Then QA engineers are like people or resources that engineering managers have. It actually means that it is not enough to slightly improve what developer did. We really expect something significant from you because you are a resource like which I have. And maybe I would prefer to have developer instead of QA engineer if QA engineer doesn't provide me enough benefit. So real outcomes are technical results, and because of that, expectations from technical perspective are higher. Actually, all the QA engineers are distributed between teams, and we don't have capacity for global initiatives and common things. So we don't have literally capacity for that. And QA strategy requires consolidation, and we have to spend a lot of time for that. Otherwise, our teams will do whatever they want to use different tools, and once we need to optimize something, it is impossible because there is no unified way how same things were done in different teams. The results that our metrics that I shared reached unbelievable level, honestly. So we didn't have such numbers before. Then such cases when we had misalignment between engineering managers and QA engineers and any hidden conflicts became visible, and we could fix them. Again, problems were in teams, but QA lead could negotiate it before. Now it became visible and we had to fix them. I think it is positive result, to be honest. Then quality was some kind of plan for QA Guild, additionally to what we are doing inside product, but now it is naturally a part of engineering strategy because all people are involved and they know that it is something needed. And of course, we can have a single direction for QA engineers now because, again, people are distributed. We need to consolidate them. We need to build QA community, and we need to be in touch with our teams and develop our quality consistently across teams. That is it from my side. If you have any questions, I am always open to discuss anything. You can find me in LinkedIn. Thanks a lot.
Great. Thank you, Anton. Yes, we do have some questions, right? So we are running over time. We're just going to take quickly 2 questions. And then, there are other sessions running parallelly as well. So there's an interesting question I see from Lisa, and I'm going to show it to you on stage. This is what she's asking.
Okay, so how big of a company is this Cymatics ideal for? Our company for now is 700 engineers. So we have more than 110 product teams. And actually, the whole this journey was together with hyper growth, I think, because when I joined Miro 8 years ago, engineering was 20 people. And you can imagine how many changes we had during that journey because the engineering grew from 20 people to 700.
Perfect. And we're going to take another one, which is interesting. How do you manage the feature flags?
Well, nothing special, to be honest, I would say. So different system like Split IO, for example, might be used for that. We used Split IO in past. Now we have another system for that. The maybe complex thing is that feature flags might be not only on client, it might not be only experiments. And so for some needs, we can have a feature flag in backend or database and I don't know, somewhere else. And I would say that we realized in the end that we have to introduce iteration platform, which combines all the stories, like how we deliver in experiments, how we manage feature flags, gradual rollout, and all of such kind of things are connected to each other. And it's probably better to consolidate all the practices in one place. So, yeah.
That's a great one. Yes. So I initially we had to take 2, but I see a very interesting question from Stefan here. Right, I'm going to show it to you on stage. Sort of generic, but this is interesting.
Oh, it's a good question, and a lot of ideas, to be honest. I would say that there are two main things which we are having in our focus. The first is consistent infrastructure. It is a challenge for us, and we are trying to solve that. Consistent means that actually any tests might be executed locally against mock like services, against real backends. It might be executed again locally in testing infrastructure and even in production, and how to keep the infrastructure and versions consistent when we have monoliths and microservices simultaneously. It is a huge challenge for us. So we are working on infrastructure setup, and the end goal is consistent environments. The second, not priority, but like hope for us is that the AI is already a great solution for a lot of different things. And from my perspective, if you have clear clarity of what we need to test, we can automate testing generally, because code for tests is quite simple and straightforward usually. We can generate tests. Of course, it doesn't mean that we shouldn't review them and design with a conscious approach when people check what we are testing and how, but the work itself might be automated pretty well, and we have quite successful POCs for that already.
Perfect. Thank you for taking that up, Anton. Guys, we're running short of time, but you have been a great audience, Anton. That was a really insightful session. We all enjoyed, a lot of attraction we see, in this session. So thank you so much for that. We want to take all the other questions as well, but we don't have time. So I'm posting our community link in the chat. There's an active LAMP test community. Just go there, post it out. You can reach out to Anton on LinkedIn as well and ask him all these questions, and he would be happy to answer. Thank you, everyone. Hope you have a great day. Yes. Thanks.